Whatever start. Okay. Good morning, everybody. Today we are going to learn about the next topic in the surveying, that is contouring. This is by G. Nagesh Kumar, Senior Assistant Professor, Civil Engineering Department, G. Pullardi Engineering College. First, definition of contouring. Contour is an imaginary line on the ground surface joining the points of equal elevation is known as contour. In other words, contour is a line in which the ground surface is intersected by a level surface obtained by joining points of equal elevation. This line on the map represents a contour and is called as a contour line. So generally a contour map will be drawn in a two-dimensional sheet on a drawing sheet, but it represents the third dimension, that is the elevation of the points can be represented by the contour line. Next, a map showing the contour lines is known as contour map. So in the contour map, only contour lines will be there. And see just at here, at the beginning, I had shown only contour lines will be there in the contour map. A contour map gives an idea of the altitudes of the surface features as well as their relative positions in plan, serves the purpose of both plan and the section. The process of tracing contour lines on the surface of the earth is called contouring. So measurement of these contour lines on the surface of the earth is known as contouring. The purpose of contouring in surveying. Contour survey is carried out at the starting of any engineering project such as a road, a railway line, a canal, a dam or a building. So for doing all these projects, a contour map is essential. We'll see each one purpose clearly. For preparing contour maps, in order to select the most economical or suitable site for a building, whatever may be. Next one is to locate the alignment of a canal so that it should follow a ridge line, so that cutting of canal will be avoided. Partial cutting, partial embankment will be sufficient. Next, to mark the alignment of roads and railway lines, so that the quantity of earthwork both in cutting and filling should be minimum. So that embankment, generally railway line will be on an embankment, and sometimes cutting may be there. So when a hill track is there, cutting will also be there. So both the works will be minimum. The cutting and embankment filling will be minimum. Like that one, you have to select the alignment of the roads by using the contour maps. Next, for getting information about the ground, whether it is flat, undulating or mountainous. So by studying the contour maps, we can understand that how the ground is there, whether it is flat or undulated, or maybe mountains are present is there, or maybe ponds are present, etc. can also be known by finding the contour map. To find the capacity of a reservoir and volume of earthwork, especially in case of mountainous regions. So by studying the contour map, we can able to estimate the capacity of the reservoir, how much water can be stored at what levels can be estimated. Also, volume of earthwork can be calculated in the mountainous regions. So for doing any project. Next, to trace out the given grade of a particular route. Grade means a slope. So by using the contour map, we can draw the road lines, railway lines with a particular grade slope, because heavy slope cannot be provided. So nominal slope should be there, so that vehicles can easily move over the grade. So particular grade, particular route grade should be followed. Next, to locate the physical features of the ground such as pond, depression, hill, steep or small slopes can also be done by using the contour map. So ponds, depression, hill, steep or small slopes can be measured. Next important one is in the contour surveying is contour interval. That means the constant vertical distance between two consecutive contours is called as the contour interval. So contour interval should be properly selected, so that The contour lines will not be very close together, at the same time should not be far away. So for this purpose, the contour interval should be properly selected based on the field. So whether it is very steep slope is there or flat ground is there, based on that one, the contour interval is selected. Next is horizontal equivalent. The horizontal distance between any two adjacent contours is called as horizontal equivalent. So the vertical difference distance between the two consecutive contours is called contour interval. At the same time, the horizontal distance between any two adjacent contours is called as horizontal equivalent. So the contour interval is constant between the consecutive contours, while the horizontal equivalent is variable and depends upon the slope of the ground. So contour interval is constant, but horizontal equivalent may be variable, depends upon the slope of the ground. Next, factors on which contour interval depends. The contour interval depends upon the following factors. One is the nature of the ground. In flat and uniformly sloping country, the contour interval is small, but in broken and mountainous regions, the contour interval should be large. Otherwise, the contours will come too close to each other. So to avoid closeness between the contours, in case of a mountainous regions, contour interval should be larger, should be selected, and in case of a flat and uniformly sloping country, you can select a contour interval is small. The purpose and extent of the survey. A contour interval is small if the area to be surveyed is small, and the maps are required to be used for the design work or for determining the quantities of earthwork. So for engineering purposes, generally this small contour interval is selected small for design works, etc. And next, while wider interval should have to be kept for large areas and comparatively less important works. So suppose if you are preparing a large area, that is a district, etc., then interval can be selected very large. Next, the scale of the map will also affect the contour interval. The contour interval should be in the inverse ratio to the scale of the map. That means the smaller the scale, the greater is the contour interval, and vice versa. The larger the scale, contour interval is smaller. Next, time and expense of field and office work. So it also depends upon the time when to produce and how much expense can be felt for the office work. The smaller the interval, the greater is the amount of field work and plotting work. So interval, if the interval is smaller, then you have to do more work. That is, field work is more as well as plotting work is more. Next, common values of the contour interval. So how to select which contour value will be taken contour interval? The following are the common values of the contour interval adapted for various purposes. So it depends upon the purpose, you have to select the contour interval. For large scale maps of flat country, for building sites, for detailed design work, and for calculation of quantities of earthwork, etc., the contour interval should be in the range of 0.2 to 0.5 meters only. Next, for reservoirs and town planning schemes, the contour interval may be selected in between 0.5 to 2 meters. For location surveys, the contour interval may be 2 to 3 meters. For small scale maps of broken country and general topographical works, the contour interval may be 3, 5 or 10 or even 25 meters may be taken. Now we'll see a very important topic in this one is characteristics of contours. So how to study the contours? By studying the contour map, we can able to understand what is there in the two-dimensional, because we cannot write on the drawing whether it is a hill or pond or maybe slope, etc., can be identified by studying the contour map. So all the points in a contour line have the same elevation. So in one particular contour line, the points will be having the same elevation. So a contour line is a line joining the points of equal elevation. So first point is that one. So every line denotes some value of the contour line with reference to mean sea level. Generally, the elevation will be shown with reference to mean sea level. Next, second one is flat ground is indicated whether the contours are widely separated and steep slope when they are run close together. When the contour lines are close together, that indicates a steep slope is presented. So on the top to bottom of a hill, the contour lines will be close together. At the same time, when the contour lines are widely separated, that indicates that there is a flat country, flat ground is there. Next, third one, a uniform slope is indicated when the contour lines are uniformly spaced. So uniform slope is indicated when the contour lines are uniformly spaced, and a plane surface when they are straight, parallel and equally spaced. So a plane surface is indicated by straight, parallel and equally spaced contour lines. Next characteristic is a hill. How hill is represented in the contour map. So a series of closed contour lines on the map represents a hill. If the higher values are inside, that is the higher values that here you can see on the hill, it is 80 meters. The contour interval taken at here is 5 meters, 75. Next contour is 75. Next contour is 70, 65 and 60. So graphically it is represented. So this circular lines indicates the contour map. So closed contour lines with a higher elevation at the middle indicates a hill. Next, reverse for it is a depression. If the contour lines are closely spaced together and having a lower value at the center and higher value at the edge, represents a depression. You can see on the graph also, the depression is like this one. The projection of these points will give the contour lines. Next characteristic is ridge or valley. Contour line cross ridge or valley line at right angles. So this is a ridge line. If the higher values are inside, the bend or loop in the contour, it indicates a ridge. Ridge line. Next, contour lines, if the higher values are outside, the bend, it represents a valley. This is a valley line. The next characteristic is contours cannot end anywhere, but close on themselves either within or outside the limits of the map. So if the map size is restricted, so the contour lines cannot end inside of the contour map. So they may be continuing out of the sheet, out of the map. Next characteristic is overhanging cliff. So contour lines cannot merge or cross one another on the map except in the case of a overhanging cliff. That means a rock like this one, hill or rock is there. The outer edge is like this. Then there is a possibility of crossing one another. Contour lines may cross one another. In such a case, we can observe that it can be a overhanging cliff. Except at this location, the contour lines will not cross each other. Next is a vertical cliff. Generally, we will cut the stone. For the purpose of stone, we will cut the hills. Then this type of a cliff will be formed. That means one side hill will be flat, another side it may be having a sloping. In the contour lines never run into one another except in case of a vertical cliff. So contour lines will meet at this single point, one point where the vertical cliff is there. In this case, several contours coincide and the horizontal equivalent becomes 0. At here the horizontal equivalent becomes 0. So many contour lines will coincide at the same point. Next characteristics is a saddle. Depression between summits is called a saddle. Depression. At here you can observe that one. Here it is a depression. This arrow mark is showing that this is a depression, this is a depression, valley line is there, and at here it is a ridge line is there, ridge line is there on either side. So if two ridges and two valleys are meeting, such a location is known as a saddle. It is represented by four sets of contours as shown. It represents a dip in the ridge or the junction of two ridges. And in the case of a mountain range, it takes the form of a pass. The line passing through the saddle and summits gives watershed line. Now we'll see how to trace the contours by different methods of contouring. There are mainly two methods of locating contours on the ground. One is direct method, another one is indirect method. First of all, we'll study about the direct method, and then we'll go for the indirect method. However, indirect method is easy for doing work. However, we must know both the methods. In the direct method, in this method, the contours to be located are directly traced out in the field by locating and marking a number of points on each contour. These points are then surveyed and plotted on the plan, and the contours drawn through them. So equal elevation points has to be identified on the ground, and then the point locations will be marked with reference to the chain tape or some tachometric methods. So like this, equal elevation points will be meted, and contour map will be prepared by using the leveling process. This method is most accurate but very slow and tedious, so it takes a lot of time. Is wasted in searching points of the same elevation for the contour. This is suitable for small area and where great accuracy is required. So when accuracy is more important, then you have to go for the direct method. Procedure: to start work, start with a temperature benchmark is established near the area to be surveyed with reference to the permanent benchmark by conducting fly leveling. The level is then set up in such a position so that the maximum number of points can be commanded from the instrument station. So at the middle, possibly at the middle, the instrument is provided so that a number of points can be covered from a single instrument station. The height of the instrument is determined by taking a backsight on a benchmark. First, you have to take a backsight on benchmark and adding it to the RL of benchmark. So reduced level of benchmark plus height of staff reading on benchmark will give the height of the instrument. The staff reading required to fix on the various contours is determined by subtracting the RL of each of the contours from the height of the instrument. So by knowing the height of instrument, to find out the contour points, the staff reading should be identified. So when the staffman is moving and putting over the surface of the ground, if the same reading is obtained on the staff, then such a points can be marked with the pegs on the ground. Example is given at here. If the height of the instrument is 82.48 meters, then the staff reading required to locate 82, 81 and 80 meters contours are 0.48, 1.48 and 2.48 meters respectively. The staff is held at any approximate position of point and then moved up and down the slope until the desired reading is obtained. The point is marked with a peg. Similarly, various points are marked on each contour. The line joining all these points give the required contour. It may be noted that one contour is located at a time. Having fixed the contours with the range of within the range of the instrument, the level is shifted and set up in a new position, and the process is continued. The new height of the instrument and the required staff readings are then calculated in the similar manner, and the process is repeated till all the contours are located. The position of the contour points are located suitably either simultaneously with leveling and afterwards. A theodolite or a compass or a plane table traversing is usually adapted for locating these points. So horizontal distances of these points with reference to the stations can be identified by using compass or plane table, or a theodolite can be used for locating this point. The points are then plotted on the plan and the contours drawn by joining the corresponding points by a dotted curved lines. Second method is radial lines method, direct method by radial lines method. This method is suitable for small areas where a single point in the center can command the whole area. So from a single station, if you complete all the points, then such locations you can use the radial lines method. So radial lines are laid out from the common center by theodolite or compass, and their positions are fixed up by horizontal angles and bearings. So from the instrument station, instrument is kept at the center and radial lines are drawn. So on this one, points will be represented at a regular intervals. So the points along this line, we have to measure the reduced levels. So temporary benchmarks are first established at the center and near the ends of the radial lines. The contour points are then located and marked on these lines, and their positions are determined by measuring their distances along the radial lines. So they are then plotted on the plan and the contours drawn by joining all the corresponding points within the help of the plane table instrument. So generally a telescopic plane table is used. So simultaneously the points location as well as the elevations can also be measured. So points can be located on the drawing sheet directly. So telescopic alidide is used in the plane table surveying, and directly you can obtain the map of the contour map of the area. Next method is indirect method. In this method, the points located and surveyed are not necessarily on the contour lines, but the spot levels are taken along the series of lines laid out over the area. The spot levels of the several representative points representing hills, depressions, ridge and valley lines, and the changes in the slope all over the area to be contoured are also observed. Their positions are then plotted on the plan and contours drawn by interpolation. The contours are drawn by interpolation. So in this one, what we have to take? We have to take a spot levels at a regular interval, and contour map can be prepared by locating the points of equal elevation by interpolation. This method of contouring is also known as contouring by spot levels. So it can also be called as contouring by spot levels. Example map is shown right here. This is a square method. In this one, we have divided the area into grids A, B, C, D, E, F, G. 7 points we have taken, about 7 points in this direction, and this direction we have taken at the same interval. Let us say uniform interval, they say 10 meters. A to B distance is 10 meters, B to C, C to D, D to E, E to F, and F to G is also same 10 meters. Similarly, on another direction, this is, let us say it is a X direction, this is a Y direction on the ground. So same 10 meters interval, we have taken a points 1, 2, 3, 4, 5, 6. So this point, this intersection point, I can call it as a B2. This is A1, this is B2, this is C3. Like that, points can be represented with a name and number. So the columns are A, B, C, D, rows are 1, 2, 3, 4 given. So this last point will be G6, G6. Like that one, you can locate the points on the ground. After marking the points on the ground, you can guard the spot levels. So same process, taking a backside on a benchmark, the height of instrument is obtained. So once height of instrument is known, So by keeping the staff over the A1 point, we can note down the observation. That is a level, reduced level can be calculated. Similarly, B1, B2, every point, at the intersection of every point, you have to note down the values. After calculations, you can find out that the values are like this one, 102.8, 102.8, 101.1, 100.6, 99, etc. is there. So all the spot levels are marked over the map, and then by interpolation, the distance between the 2 points is, let us say this is 10 meters. So at here, the reduced level of the point A2 is 101.1, and at here it is 100.8. So 101 contour is lying in between these 2 points. So 101 contour will start at somewhere. So this location of this point can be identified assuming that there is a uniform slope between the 1 and 2 points, A1 and A2 points with a uniform slope. So by interpolating, we can obtain the point at here. Let us say the difference is 100.8 and 101.1. That is 0.3 meters. 0.3 meters in 10 meters length. Vertical difference is 0.3 meters in horizontal distance of 10 meters. That is about 1/3 the point is located near this 100 or not one contour is located. Similarly, all the points will be marked on the map. So field work is very easy, and map work will be some calculations are required. But here again you can see that 101.1 and 100.9 these spot levels. So in between them 101 is there. 101 point. So just it may be at the middle of this, because only 0.2 is the difference in 10 meters. So at the middle of it, you can get it. So at here 101 is clearly given. So it was passing through these points. Like this, points will be identified on the drawing sheet. Those are marked with the curved line. The line joining the points will be curved line. So this method is commonly employed in all kinds of survey, as this is cheaper, quicker, and less tedious as compared to direct method. There are mainly 3 methods of contouring in indirect method. Again, there are sub methods are there by squares. In this method, the whole area is divided into number of squares, the side of which may be vary from 5 to 30 meters, as much as 30 meters, depends upon the nature of the ground. If the ground is undulated and hilly area, then you have to take the 5 meters. And if the ground is very flat, then you have to go for the 30 meters. The square need not to be the same size throughout. Throughout the map, it is not required to be same. So you can vary, depends upon the ground location. The second one is indirect method is square method. The corners of these squares are pegged out, and the reduced level of these points are determined with a level. So the square method. So pegs are driven at each intersection point, and spot levels are taken at each and every point. 1, 2, 3, 4, 5, 6, 7, 8, like that one. You can take the, and then contours are interpolated. So these contour values are marked at here. By interpolation, already I had explained the interpolation. We can obtain the points of equal elevation. Is joined with a smooth curved line. Next, the important points within the squares may be taken when required and located by measurement from the contours. The squares are plotted, and then reduced levels of the corners are written on the plan. By cross sections. This method is most suitable for survey of long narrow strips such as a road, railway line, or a canal. So center line is marked right here. Center line is marked. Along the center line, generally road will be, let us say, 20 meters wide. So on either side 5, 5, 10 meters, and 5, 5, 10 meters will be taken. Generally, not more than 10-20 meters road width will be there. So the contour requirement is only up to 20 meters and 10 meters on either side of the center line will be taken. So along this length center line, we have to take on either side, left side and right side, the contours. If the line is moving in this direction, chain line is moving in this direction, left 1, left 2 points will be taken, L5 and L10. Similarly, R5, R10 will be taken. So a longitudinal section is plotted. So the contour of the points can be obtained by same method, that is reducer levels are marked on the map. With reference to the reducer levels, the contour line will be represented. Let us say it here 70.6 and 69.1. So in between them, there is a contour 70. 70 contour is plotted. So similarly, at here also 71.2, 69.1. In between them, 70 point contour is there. So joining all these points, you can obtain the contours. At here, 5 contours are got. One is 69, 70 and 71 is there. 3 contours are there. 71. 71 is out of the drawing. By cross section, this method is most suitable for surveys along narrow strips such as road, railway and canal. Cross sections are run transverse to the center line of the work, and representative points are marked along the lines of cross section. The cross section lines need not necessarily be right angles to the center line of the work. So this may be inclined at any angle to the center line if necessary. The spacing of the cross sections depends upon the topography of the country and the nature of the survey. So the cross sections may not be uniform, depends upon the nature of the country. So this is 540 meters and this is 560 meters. 20 meters interval at here contours are the cross sections are drawn. Next, indirect method concept. The common values of 20 to 30 meters in hilly country and 100 to 100 meters in flat country will be taken. The levels of the points along the section lines are plotted on the plan and the contours are then interpolated as usual, shown in the figure. So another method is there, indirect method, that is called as a tachymetric method. Tachymetric method. A tachymeter is a transit theodolite having a diaphragm fitted with the 2 stadia wires, one above and one other below the central wire. The horizontal distance between the instrument and staff stations may be determined by multiplying the difference of the staff reading of the upper and lower stadia wires with the stadia constant of the instrument, which is usually 100. So thus tachymeter is used for both the vertical as well as the horizontal measurement. So by using these stadia hairs, the distance from the instrument station to the staff station is obtained, whereas horizontal line will use the reducer level of the point. That is staff reading is taken. From that one, you can calculate the reducer level. So simultaneously, both the horizontal distance as well as the elevation of the point can be identified. So this method is most suitable in hilly areas as the number of stations which can be commanded by a tachymeter is far more than those by a level, and thus the number of instrument settings are considerably reduced. A number of radial lines are laid out at a known angular interval and representative points are marked by pegs along these radial lines. Their elevations and distances are then calculated and plotted on the plan, and the contour lines are then interpolated. Next is interpolation of contours. The process of spacing the contours proportionally between the plotted plotted ground points is termed as interpolation of contours. That means location of the contour points of equal elevations on the plotting is known as interpolation of contours. This becomes necessary This becomes necessary in the case of indirect contouring, as only the spot levels are taken in this method. While interpolation of contours, the ground between any 2 points is assumed to be uniformly sloping. So at here one assumption is that is while interpolating the ground between the 2 points is assumed to be uniformly sloping. Actually, it is not there in the field. There are 3 main methods of interpolation. One is by estimation. The position of the contour points between ground points are estimated roughly and the contours are then drawn through these points. This is a rough method and is suitable for small scale maps. Next is by arithmetical calculation. This is a very tedious but accurate method and is used for small areas where accurate results are necessary. The contours are interpolated as under. By arithmetical calculations, suppose A and B are the 2 points at a distance of 30 meters and the reduced level of A and B are 25.45 meters and 27.54 meters respectively. Taking the contour interval as 1 meter, 26 and 27 contours may be interpolated in between A and B. The difference of level between A and B is 2.09 meters. The difference of level between A and 26 meters contour and A and 27 meters contours is 0.55 and 1.55 meters respectively. Therefore, the horizontal distance between A and 26 meters contour is given by 0.55 divided by 2.09 into 30 and between A and 27 contour is given by 1.55 divided by 2.09 into 30 meters. These distances are then plotted to the scale on the map. Next, third method is generally graphical method. This method is not required. Generally, graphical method very difficult. And drawing the contour lines. Contour lines are drawn as fine and smooth freehand curved lines. Sometimes these they are represented by broken lines and they are inked in either black or brown color. A drawing pen gives a better line than a writing pen, and French curves should be used as much as possible. Every fifth contour is made thicker than the rest, so that easily you can read out the contour map. The elevation of contours must be written in the uniform manner, either on the higher side of the or in the gap left in the same line. Gap left in the same line is better. When the contour lines are very long, their elevations are written at 2 or 3 places along the contour. So in the case of a small scale map, it is sufficient to figure every fifth contour. Okay. Now we will see what are the uses of contour map. So we have studied how to draw the contour map. So for what some uses will be there, that a contour map furnishes information regarding the features of the ground, whether it is flat, undulating or mountainous. From the contour map, sections may be easily drawn in any direction. So X direction, Y direction also you can get the sections of the ground. Intervisibility between 2 ground points plotted on the map can be ascertained, and it enables an engineer to approximately select the most economical or suitable site for an engineering project such as road, railway line, canal or a pipeline work. A route of a given grade can be traced on the contour map. Catchment area and capacity of a reservoir may be determined from the contour map. So contour map may be used to determine the quantities of earthwork also. Okay, with this we'll stop.